Hello, everybody, and welcome back to a new semester with a new course. Today, we are considering a senior course targeting what we can call a multidisciplinary topic in electronics under the term selected topics in electronics engineering. So from the name of the module, you can estimate that this somehow a floating module that can have a variable content from one semester to another. And during this semester, we have selected together to have our topic under the main umbrella of what we can call system on a chip, or typically sensor on chip. So with referring to our zero lecture dealing with the main course outline, you will find that I use this abbreviation, let me say, or this subtitle for this for the course under the sensors on chip as the headline or the subtitle for our this semester course. Actually, the word on a chip is somehow an attracting word in the electronics industry nowadays. How to integrate, how to merge, how to combine everything in your system to be on a chip. But to be more detailed in the description of this module, I would say that we are considering the SLC or the sensor on chip, or maybe the system on chip, from the analog perspective. As you can know that most of these systems include a mixed analog digital environment. So during this course, we are giving more focus toward the analog interfacing circuits and the analog circuits related to such system on a chip circuits or schematics. So our concern is sensor on chip. And based on this, we are going to investigate not only sensors, but actually the interfacing circuits and other energy management circuits related to sensors. So if we go deeply into the modular scope, we are going to demonstrate various types of schematics used for sensors. Maybe the word sensor is a very broad word that or a broad term that include different types and as different technologies of sensors. But during this course, we are going to be more oriented toward what we can call the CMOS sensors, or these sensors that can be implemented using the CMOS technology. Additionally, we are going to highlight also some up-to-date sensors using new technology. Maybe we can consider it between quotation nanotechnology, like, for example, when we consider organic field effect transistors as an advanced technology of transistors using organic semiconductor materials in order to perform some sort of a sensing mechanism. This sensing mechanism can be biomedical sensing or can be a gas or environmental sensor. So this is one of the examples for making or for having a sensor. Additionally, all these sensors should be back-ended by what we can call an interfacing circuit that is capable of collecting data from the sensor and giving it to the digital part of the node. And this also will be one of the aspects or one of the points to be discussed during this module, how we are going to implement such schematics to have a good interfacing circuit, and actually how to evaluate the interfacing circuit, how we can say that this is a good or this is an appropriate interfacing circuit or not. Also, we are going to consider some schematics maybe partially shifted toward RF and optics when we consider some schematics related for transceivers, for example, because one of the very famous applications for the SoC systems is the IoT applications and the wireless sensor networks. And in these applications, you need some sort of a transceiver. It can be an RF transceiver, it can be an optical transceiver. So we are going to consider also some schematics in this direction Maybe also we can, if we have some time, we will consider also some related interfacing circuits related to wireless power transmission. Again, this wireless power transmission can be a near field or far field, can be RF, or it can be, sorry, inductive capacitive resonance, or it can be microwave or optics. So, or maybe what we can call a laser wireless power transmission. So this will be also one of the parts to be discussed under this module. Finally, as you know, this is an advanced edge level module, and usually in such modules we have to embed topics that catches the most recent up-to-date technology. And one of these technologies, or maybe concepts nowadays, is what's called informatics, or how you can use informatics to optimize and even to understand and predict your devices. This usually happen by embedding some sort of machine learning algorithms, or maybe artificial neural networks or something like that. So we are not going to make this into deep details because this needs a lot of time, but at least we are going to make some sort of show on how such artificial intelligence algorithms can play a role in the optimization, understanding, and the prediction of electronic circuit design, and typically in our case for sensors. This is a very short briefing for the list of content of our module. As I demonstrated, we are going to focus on sensors, we are going to focus on interfacing circuits, and as well as some sort of RF circuits, and finally informatics. We hope, let me say that we hope to have the opportunity to reach a complete schematic for an IoT sensor, for example, with its transceiver, the sensor itself, the interfacing circuit for the sensor. Maybe also those who have already studied the energy harvesting course can embed some self-powered mechanisms using energy harvesters with its related or associated circuits as a DC-DC converters or whatever. So this will be part of the big story we are going to discuss during this semester, inshallah. As usual, you can follow up this lecture, of course, beside attending the physical lecture, you can also be with us using the related playlist in the YouTube channel. So you will find the link in the slides, and also you will find it over the e-learning page as well. Concerning the assessment, the course is a typical 60-40 course with 60% unseen, and we have a 20% for the in-class test, and we have another 20% for project. It will be a group project. Maybe it's more better to make more demonstration about the project during the physical lecture. However, generally speaking, the main expected outcome of this project is to have the know-how to make a complete IC design, starting from making a schematic, a simple schematic. Most likely we will start with a tool which you are already familiar with, like for example Multisim, and then we are beginning to use some sort of an industrial tool. Most likely I will propose here using Cadence for that, and then we make the complete process till we reach a layout. And I think this is the main added value for the project, is to know how to make a complete process till to reach a layout. Thank you very much for this very short introduction lecture. Maybe in the next lecture, inshallah, we are going to go into the sensing mechanism. We'll start with a CMOS temperature sensor, and then we will accelerate toward more advanced sensors in the biomedical and also in environmental sensors. I thank you very much for your concentration, and let me start the course officially by the coming lecture number 1. Thank you very much.